Hello and welcome back to Engineers Olympiad, where learning meets success. We have completed the first chapter of surveying, that's Introduction and Basic Concepts. Now we'll start another chapter of surveying, that is Theory of Errors. So let's begin. In surveying, as you all know, we deal with the measurements of distances and angles. All right. We take the various measurements in the field. We measure the horizontal distances, the vertical distances, the horizontal angles, or the vertical angles. We do the computations in the office, and the plans and maps are subsequently prepared of that area that is being surveyed. But it must be known that it's almost impossible to determine the true value of these quantities. Why? Because some errors will always creep in your measurements. All right. So these measurements of angles and distances, it's impossible to determine their true values because these quantities will always suffer from some errors. The errors will always creep in every measurement of yours. So this true value of these quantities will never be known. And how are these errors caused? What is their cause or source? They occur either due to imperfection in instruments, or due to human limitations, or due to changes in environmental conditions, or due to carelessness on the part of the surveyor who is taking these measurements. All right, students. So in surveying, we deal with the measurement of angles and distances, but their true values cannot be determined because some sort of errors will always creep in every measurement of yours, and these occur due to imperfection in instruments, human limitations, changes in environmental conditions, or carelessness on the part of the surveyor who's taking these readings. So our motto should be that errors which still creep in, they should be either eliminated. Let me write it here. Let me write it here. These errors should be either eliminated or their effects should be minimized. All right. So the true value of such quantities, your measured distances and your measured angles, will never be known. And what is this true value? The true value of a quantity is a value which is absolutely free from any type of error. All right, students. So true value of a quantity is that value which is absolutely free from all types of errors. So a surveyor must know the various types of errors, how they occur, and how they can be controlled. So this chapter, the theory of errors, deals with this thing: the sources of errors, the causes, the nature, the types, their propagation, and how they can be corrected, or how their effect can be minimized. All right, moving on. These are very two important terms in this chapter: accuracy and precision. What is accuracy? Accuracy of a measurement denotes its closeness to its true value. All right, students, so accuracy denotes the closeness of a measurement to its true value. For example, if a measured value is very close to its true value, then we'll say it's very accurate. Or if it's far from its true value, we'll say that measurement is not that accurate. All right. So accuracy indicates the nearness to this thing, true value. All right. It is degree of perfection achieved in measurement. What? Accuracy. It's the degree of perfection achieved in measurement. And it denotes the closeness of a measurement to its true value. Now, what is this thing, precision? Precision of a measurement denotes its closeness to another measurement of the same quantity. All right? Precision denotes closeness to another measurement of the same quantity. All right? If a quantity is measured several times and the values obtained are very close to one another, we'll say the precision is high. If a quantity is measured several times and every time the value we get, they are quite close to each other, we'll say our precision is high, and vice versa. And every time we measure the value of any quantity and it's close to its true value, we'll say our accuracy is high. All right. So students should clearly understand the difference between accuracy and precision. Whereas precision denotes the degree of agreement between several measurements of a quantity, the accuracy denotes its closeness to its true value. For example, let us take an example. Let me rub it first. Let us suppose a distance may be measured very precisely with inward tape. All right, we are making use of an inward tape to measure the distance. But still, it may not be accurate if the tape has faulty length of, let's suppose, instead of its nominal length of 30 meters, it has an erroneous length of 30.10 meters instead of its nominal length of 30 meters. All right, so the measurement done with such a tape may be quite precise. Every time we'll take a measurement, the measured values will be quite close to one another. That means the precision is high. Precision is high, but your accuracy will be low because your measured values are not close to the true value of that quantity. All right. So this is about accuracy and precision. Whereas we can say that precision is the degree of perfection used in instruments, the methods, and observations. But the accuracy is the degree of perfection obtained. All right. And we also know this, as we have discussed this in the first chapter, that a good surveyor should always try to achieve both precision as well as accuracy. A good surveyor should try to achieve both accuracy and precision. And it's possible only if the measurements are taken carefully using the precise instruments and the correct methods. If a surveyor makes an use of precise instruments and he applies the correct methods, it's quite possible that he'll achieve both the things, precision as well as accuracy. All right. But unfortunately, the cost of survey work increases rapidly with an increase in accuracy. It was also discussed in the first chapter that with an increase in the accuracy, the cost of survey work also increases. It requires more time, more effort, and more money. And it requires costly instruments. All right. So the degree of accuracy necessary for a particular work will depend upon the purpose of survey. All right. So the surveyor should take measurements which are correct to a certain degree, but at the same time, which is good enough for the purpose of a particular survey. All right. So this was about accuracy and precision. Moving on, let's study about sources of errors. So as already discussed that some type of errors always creep in every measurement a survey takes. But what are these sources? This can be classified into three types: instrumental errors, personal errors, and natural errors. All right, students, so we have three types of sources of errors: instrumental, personal, and natural. What is instrumental? Errors may arise due to imperfection or faulty adjustment of the instrument, as already discussed, and this will cause an error in our measurement taken. For example, a tape may be too long or an angle measuring instrument may be out of adjustment. If, for example, let's suppose our tape is does not have the nominal length, there will be an error in the measured distance by that tape. Or let's suppose our angle measuring instrument is out of adjustment. If it's out of adjustment, it will cause an instrumental error. All right. So this is the source of error which creeps in from the faulty instrument you are using while taking your measurements. Next one, personal. These personal errors occur due to want of perfection of human sight in observing and of touch in manipulating instruments. All right. For example, let's suppose an error may be there in taking the lever reading or reading an angle on the circle of a theodolite. All right. For example, if you had to read an angle, let's suppose 181 degree, but instead of that, you read an angle, let's suppose 179 degrees. So this falls under the category of personal errors. The personal errors occur due to human limitations of sense of sight and touch. All right. Human limitations, sense of sight or touch. The errors which creep in by those limitations fall under the category of personal errors. All right, let's study the third one, natural errors. These errors occur due to variations in natural phenomena such as temperature, Which errors? These natural errors: temperature, humidity, temperature, humidity, gravity, wind, magnetic declination, etc. All these cause your measurements to have some sort of errors. As already discussed, let's suppose you use a tape which was calibrated at certain temperature, and while you're taking measurement by that tape in the field, you found different temperature, so there will be an error, and this error falls under the category of natural errors which occur due to variations in natural phenomena such as temperature, humidity, gravity, wind, magnetic declination, and refraction, etc. All right, so this was about the sources of errors. Let's study about types of errors. All right, as already discussed, a surveyor should have knowledge of different types of errors, their sources, their characteristics, and their behavior. A surveyor should have the knowledge about sources of errors, their types, their characteristics, all right, which will help him to minimize their effects. Now, as we have studied about the sources of errors, let's study about various types. The various types of errors are kinds of types of errors. First one is mistakes. The second one, systematic errors. And the third one, random or accidental errors. All right, so we have three types of errors: mistakes, systematic errors, and accidental errors. And as far as possible, the surveyor should avoid these errors. And if they are unavoidable, their effect should be minimized by applying various corrections. All right, so let's study this first: mistakes. Mistakes occur in measurements due to carelessness, inattention, or inexperience, or let's suppose poor judgment of the surveyor. First one, mistakes. These occur due to carelessness, inattention, poor judgment, all right, or inexperience on part of a surveyor who's taking these measurements of angles and distances in the field. So the errors which will occur in our measurements due to all these things will fall under the category of mistakes. Mistakes are quite common in a careless work. If a surveyor, for example, he reads 16 meters on a tape, let's suppose he reads 16 meters on a tape, but he had to read correct value was 19 meters. So this will fall under the category of mistake. Or let's suppose a surveyor calls out 7 meters, but it was booked as, let's suppose, 8 meters in the field book. So this will also fall under the category of mistakes. So mistakes are those errors which occur due to carelessness, inattention, poor judgment, or inexperience on the part of the surveyor who's making these measurements in the field. All right, these mistakes are also known as blunders or gross errors. We may call these mistakes also by the name blunders or gross errors. But fortunately, these large mistakes can be easily detected if suitable check measurements are being taken. If we'll take check measurements in the field, we may easily detect large mistakes. But an undetected mistake may cause a very serious inaccuracy in measurement, and this may lead to a faulty survey. All right. So, students, these types of errors which occur due to carelessness, inattention, poor judgment, or inexperience on the part of surveyor who's taking these readings, these fall under the category of mistakes, which are also known as blunders or gross errors. But there is a thing that these mistakes can be easily detected if we'll take suitable check measurements in the field. All right. These mistakes are random. This must also be noted that mistakes are random in nature. Mistakes are random in nature because they do not follow any fixed pattern. They do not follow any fixed pattern, so they are random in nature. This mistake may be positive or negative. A positive makes a result. These mistakes may be either positive or negative, and a positive mistake makes a measurement too large, and a negative mistake makes a measurement too small. All right, so this was about the first type of error, which is known as mistake, or it is known as blunder or gross errors as well. All right, let's study the next one. Next one is the systematic errors, which are also known as cumulative errors. Systematic errors or cumulative errors. A systematic error or a cumulative error is an error that under the same conditions will always be of the same size and sign. All right, students. So a systematic error is an error which under the same conditions will always be of the same size and sign. And the systematic error always follows some definite mathematical or physical law. So our systematic errors or cumulative errors always will be of the same size or sign under the same conditions, and these follow some definite mathematical or physical law. And a correction can be determined and applied to minimize its effect. Whose? Systematic errors. All right. And these errors, systematic errors, they are of constant character. This must also be noted. And they will always be of the same size and sign under the same conditions. For example, if a tape is p centimeters short, let's suppose we're taking a tape and it's p centimeters short. All right, and if it's stretched n times, we're taking a tape which is p centimeters short, and if it's stretched n times, the total error in the measurement of the length will be how much? Pn centimeters. All right, so if we'll take a tape which is p centimeters short, and if it's stretched n times, the total systematic error in the measurement of the length will be Pn centimeters. All right, so these systematic errors follow some well-defined mathematical or physical law. All right, let's study. And they're also known as cumulative errors because their effects, they are cumulative in nature. For example, systematic errors are also known as cumulative errors because they are cumulative in nature. It's in their nature. They are cumulative. For example, as we studied, if we made a measurement with a tape which was p centimeters short and we stretched it how many times? N times. The result, the error in our measurement was Pn centimeters. So they are cumulative in nature. They have cumulative effect. Right? Let's study about the last type or kind of error, which is known as accidental errors. They have other name, compensating errors. All right. So accidental errors or compensating errors are those errors which remain in your measurements after all your mistakes and systematic errors have been eliminated. Your systematic error has been eliminated from the measurement. The mistake has also been eliminated, but the error which will still be there will be this type of error, accidental error or a compensating error. And these are caused by a combination of reasons which are beyond the ability of observer to control. These accidental errors or compensating errors, they're caused by the reasons which are beyond the ability of the observer to control. All right, they tend sometimes in one direction and sometimes in the other. So they are equally likely to make the apparent result either too large or too small. All right. So our accidental errors, they have the tendency that they are equally likely to make your apparent result either too large or too small. These accidental errors are random in nature, all right, because they do not follow any fixed pattern or law, unlike systematic errors. All right, and these are the errors in your measured quantities after your mistakes and systematic errors have been eliminated or corrected. For example, accidental errors are directly proportional to, for example, if you take n number of measurements in the field, these are directly proportional to square root of n. This must be noted by the students that accidental errors are directly proportional to square root of n, where n is the number of observations made. All right. So this was about accidental errors, which are random in nature and they do not follow any law, but they follow the laws of chance. They do not follow any mathematical or physical law, unlike systematic errors, but they definitely follow laws of chance. And the theory of probability can be used in dealing with these type of errors. Which errors? Accidental errors or the random errors, which occur in your measurement after all your systematic errors and mistakes are removed. The accidental errors, as already discussed, they obey the law of chance, and these can be handled according to the mathematical theory of probability. See this chapter, theory of errors. This only deals with these type of errors, accidental errors. All right. So the error here and after in this chapter, wherever we'll be dealing, these will be this type of errors, accidental errors. All right. So this was about the basic introduction of the chapter, accuracy and precision, true value, the various sources of errors and various types of errors. With this, we conclude this video of lecture. Thank you for watching.